Hello everyone, welcome to the channel. In this video, we are going to discuss about the Hilbert second problem. Okay, so Hilbert second problem over here it is stated as upon closer consideration, the question arises whether in any way certain statements of single axioms depend upon one another and whether the axioms may not therefore contain certain parts in common, which must be isolated if one wishes to arrive at a system of axioms that shall be altogether independent of one another. But above all, I wish to designate the following as the most important among the numerous questions which can be asked with regard to the axioms. To prove that they are not contradictory, that is, that a definite number of logical steps based upon them can never lead to contradictory results. So, from the second problem, okay, we have two parts. So, the first part is to ensure uniqueness. And non-overlapping set of axioms. Using which any statement can be proved or disproved. So this is the first part. The second part of the problem is the set of axioms are complete and consistent. So from this we can see if there is a set of axioms which are complete and consistent, so anything logically derived from these axioms will also be complete and consistent. Okay, I repeat again, if we have axioms which are complete and consistent, so logically, if we are deriving anything logically from these axioms, so that will also be complete and consistent. But over here, we are assuming that logic is complete and consistent. So now to prove completeness and consistency of maths, we have to first prove that logic is complete and consistent. Okay. So now in maths, we have to first prove that logic is consistent and there exist set of axioms. Okay. There exist set of axioms using which any statement can be proved or disproved. Okay. So once we have set of axioms and rules of logic, we can mutate axioms into statements and prove the completeness and consistency of maths. So now the turning point over here is that Gödel proved that we have set of rules which are complete and consistent. Okay. But it is impossible to have a set of axioms which are complete and consistent, which is called Gödel's incompleteness theorem. Okay, the rules of logic. Okay, logic is complete. Logic is complete. And this is what? Gödel's completeness theorem. But to have set of axioms which is complete and consistent, it is impossible. Okay, it is impossible to have set of axioms which are complete and consistent, which this is called Gödel's incompleteness theorem. So Gödel showed that any set of axioms set for arithmetic will be either consistent or complete, but not both. So any theory that is dealing with the numbers will prove some false statements, or it will not prove some true statements. Now, what is the impact of this incompleteness theorem? That we'll see in the next video. Thank you.